This is the, excuse me, this is the pre-calculus, excuse me, pre-calculus chapter 5 review um, for our upcoming test. So number one is telling me to write log to the base 4 of 81 equals x in exponential form. And so that would be, it's the base to this power, so 4 to the x equals 81. And I think that I probably meant for this to come out even, but obviously I can't write 81 in base 4. So it's not going to come out even, which means that I have to use the natural log to solve. So this is x times the natural log of 4 equals the natural log of 81. So x is the natural log of 81 over the natural log of 4. And then we would go to our calculator and figure that out. If this had been a problem, log to the base 3 of 81 equals x, then that would have been 3 to the x equals 81, and 81 is 3 to the 4th. And so x would equal 4. I think that that's probably what I intended to put on there, but did not, obviously. So there's both ways to solve that if it doesn't work. And then number 2, a natural logarithm has a base of, the answer would be e. The base of the natural log is e. And then number 3, the default of the common log is base 10. So the common logarithm, we're just talking about log base 10 of whatever. So the base of the common log is 10, and that's what your calculator defaults to. I think that's why I put that word in there. Number 4, I have 5 to the 3rd times 5 to the negative 4 over 5 to the negative 3. And, like always, there's a multitude of ways I could get started. Here's how I would get started. I would combine my numerator. And when you have the same base raised to these exponents, you add the exponents. So when I add those exponents in the numerator, I get 5 to the negative 1 over 5 to the negative 3. Then you can think of this as, I'm going to bring this up to the numerator, and it'll be a positive 5 to the 3rd, which is probably the way I would think of it. And then add those exponents, and my answer is 5 squared, or 25. Another way to think about it is subtracting. When I divide, I subtract the exponents. And negative 1 minus negative 3 is positive 2, and then 5 squared. If this is something, if this exponent turns out to be like 15, if the answer turns out to be 5 to the 15th, obviously it would be okay to leave it as 5 to the 15th. You don't need to change that, but 5 squared is not difficult to change. So let's see, I have the square root of x to the 5th times the square root of x squared. And we had something similar to this on a quiz. We changed that to x to the 5 halves times x to the 2 halves, which is x to the 1. And then adding 5 halves plus 1 is 7 halves. And so that's what we're looking for in that answer. 8x, the negative 3/4 times 3x, the 1/4, over 2x to the negative 1/2. Okay, well, 8 times 3 divided by 2, because none of those are being raised to a power. None of those are involved in this exponent that's on x. So I can just do 8 times 3 divided by 2 is 12. And then I could do -3/4 plus 1/4. And then when I bring this up, I could write minus -1/2 or plus 1/2. And 1/2 is 2/4. So it looks like I have -3 plus 1 is -2 plus 2 is 0. So this is 12x to the 0, which is 12. Anything to the 0 power is 1. 3 to the -1 minus 3 to the -2 all to the -1. Well, this is, a little bit more complicated than the previous problems because of this minus in here. What that means is that I cannot, do this, right? I have to get a common, fraction. I have to get a fraction, get denominator, and get this written as one fraction so I can flip it over, because that's what the -1's going to do. It's going to flip it over. So I rewrite this as 1/3 minus 1/9 to the -1. And 1/3 is 3/9, and 3/9 minus 1/9 is 2/9. And that's all to the -1, so that is 9/2. Number 8, we have 81 x to the 12th to the -1/4. Okay. So this one, they are both being raised to the -1/4 power. So I can take 81 to the -1/4 times x to the 12th times -1/4. 81 to the -1/4 is 1 over the 4th root of 81. And then that's going to be 1 over x to the 3rd. And the 4th root of 81 is 3. So my answer is 1 over 3x to the 3rd. Number 9 has 3x to the 4/3 over 3x to the -2/3. So again, those 3's are not being raised to any power. So they are going to cancel. And if I subtract these exponents, 4/3 minus -2/3 is 6/3. And 6/3 is 2. So that simplifies to x squared. Okay, number 10 has 4x all to the -2 equals 64. So I don't know if you remember, but we did problems where we had to use, match the bases, and we reserve that for when x is in the exponent. X is not in the exponent here, so I just need to solve. This 4x to the -2 is 1 over 16x squared equals 64 over 1. And I'm going to bear with me for a second here. What I'm going to do is multiply 16 times 64, and I'm going to get 1,000. When I cross multiply here, I'm going to get 1,024 x squared equals 1. So x squared is 1 over 1,024. And that is not, well, it is a perfect square. I take that back. Now I take the square root of both sides, okay? And I get x equals plus or minus 1 over 32. All right, number 11. We have 5 to the x equals 125 over 25 to the x. And obviously I have x in the exponent, so this is one where I need to match the bases. And everything's going to go to base 5, which this already is. 125 is 5 to the third, and 25 is 5 squared. And then this is going to be 5 to the x equals 5 to the 3 minus 2x. When you're dividing, you subtract those exponents. And now I can set the exponents equal. X equals 3 minus 2x. I would add 2x to both sides, and x is 1. Number 12, I have log x equals -3. And so there's no base written on that, so it's base 10. So basically, x equals 10 to the -3. And 10 to the -3 is 0.001. 13, I have log to the base x of 64 equals 2/3. Okay, so if I apply the definition here, I get x to the 2/3 equals 64. And I would raise each side to the 3/2 power. And so over here I get x. 64 to the 3/2, I could run to my calculator and do 64 to the 3/2. I could also take the square root of 64, which is 8, and then cube it. You get 512. Okay. 15. Supposed to evaluate log to the base 6 of 36 square root of 6. So that means I set this equal to x. So 6 to the x is equal to 36 times the square root of 6. And obviously I need to match the bases because I have a variable in the exponent. So 36 is 6 squared, and square root of 6 is 6 to the 1/2. So 2 plus 1/2 is 5/2, right? And now that I have the same base, x equals 5/2. 15. Log to the base 4 of 2 plus log to the base 4 of 6 minus log to the base 4 of 3. So these first two would combine to be log to the base 4 of 12. And then log to the base 4 of 12 minus log to the base 4 of 3 would be log to the base 4 of 4. Log to the base 4 of 4 is 1. That worked out nice. Um, 16. It's telling me that log m equals x and log n equals y. So I'm supposed to express log of n over the square root of m in terms of x and y. And so what I need to do is I need to make that look like log m and log n, okay, by themselves, not all combined like they are now. So first thing I can do is write this as log n minus log square root m, because I can change that division into a subtraction and separate the logs. Then the next thing I can do is that's log n. This is m to the 1/2, so I could make that 1/2 log m. And now I can substitute in x and y. Log n is x, or I'm sorry, log n is y, and log m is x. And so your answer is y minus half of x. This has log of mn to the 5th. So I think what I would do is I would make that log m to the 5th, n to the 5th. And then make that log m to the 5th plus log n to the 5th. And then 5 log m plus 5 log n. And now I'm ready to put in, to substitute x and y. So I get 5x plus 5y. I could have pulled that exponent down in front, from here. I could have pulled that down in front over to here, and I would have gotten 5 times the quantity, log x plus log y, which is the same thing. Or I'm sorry, log m plus log n, which is the same thing as what I've got here. I would have 5 times the quantity, and then we could distribute it or not. Okay. So number 18. A radioactive element has a half-life of 12 days, and we have 2,000 grams are now available. How much after 30 days? So the formula of the formulas that I gave you, the one that we want to use here is the A of t equals a sub 0 times 1/2 to the t. Oh shoot, I lost it. To the t over k. And so my original amount is 2,000. The time is 30 days, and the half-life is 12 days. And so I can go to my trusty calculator and put in 2,000 parenthesis fraction 1/2 parenthesis to the fraction 30 over 12. Okay, so I have it in there exactly the way it's written. I press enter. 353.55. So the question asks how much will remain after 30 days? Approximately 353 point, we'll say 6 grams. And number 19, I guess is what we're on. If you invest $8,000 at 6.5% annual interest compounded monthly. How much we have after 6 years? How much after 6 years? So the equation we want to use for this is the A of t equals A sub 0 times the quantity 1 plus R over K to the TK. So our initial amount of money is 8,000. 1 plus R is 0.065 over, it's compounded monthly, so K is 12. And then that's going to be for 6 years, and then times K, which is 12. So again, go to our trusty calculator here, and I can type in 8,000 times 1 plus 0.065 over 12 to the, oops, don't need a fraction, never mind. Nope. To the 6 times 12. You know, it's weird, but the most common mistake I see on this problem is that people use 0.65 rather than 0.065. Just use the wrong decimal to represent the percent. Not sure why, but that's the most common mistake I see. And we're going to have, at the end of 6 years, we're going to have $11,803.42. So we're going to have approximately 11,803.41729. So how much money is that? 11,803.42 cents. Those were fun. 6 to the x equals 24. So when I was writing this, I didn't think that we had enough problems where we actually had to use a natural log to solve, which is what we need to do here. The natural log of 6 to the x equals the natural log of 24, because I can't match the bases. There's no 24 is not 6 to any power. So I have to use the natural log to solve. And so x is the natural log of 24 over the natural log of 6. And there is no way of simplifying that. Okay, we've talked about that in class. This cannot be simplified. The only way I can get that decimal is to do that division, to actually take and do the natural log of 24, and we can even write it as a fraction with the natural log of 24 over the natural log of 8, and we get 1.528. And we could call it whatever, probably 1.53. Okay. And then 21, just to re-emphasize that, excuse me, e to the ln of x is x. And I was looking at that last sentence up above these problems, and I did not do the second part of 19, which is about how many years does it take to double your money. And so for that, we would use the rule of 72, because it says about. It doesn't want us to, actually put it into an equation and say, 16,000 equals 8,000, and then solve for the time. If I wanted that information, I would have said, how many years is it going to take to double my money? But because of the about in there, that says I can take 72 divided by 0.065. I'm sorry. When we put that in there, we divide by the percent. It's 72 over R percent. So I'm going to divide by 6.5. 72 divided by 0.5, and it's going to take approximately 11.1 years to double. Okay, that looks like everything. Something wasn't clear, you need help with anything, make sure you get in to see me. Otherwise, it'll be a good test.